All right, so this problem, we're going to do this one here where you've got these bricks and they're 40 kilograms. You've got these wires, um, and we want to know how much force are the wires exerting along the direction of the wires. So we're looking for a tension force here. We know the angle is 25 degrees. So first thing we'll do is do a free body diagram. So free body diagram gives us this. This is kind of showing in general what the shape is. This is the FBD. This is the bricks. We've got two forces of tension. They're not maybe perfectly the same, but they're meant to be the same. And we've got this here at 25. Now, if this were a 90-degree angle here, we might be looking at a different story, but this is not a 90-degree angle, so we're going to need to break down both of these forces. And they're symmetrical, so that's going to work out okay. We've got FTX, and we've got FTY. Same thing on this side. FTX. We've got FTY. Since we know the y direction, we're going to use the y direction. We also know that we've got the force of gravity on here, which is equal to mass times gravity, and that's going to be 392.4 because the mass is, again, 40 kilograms. So, but we can write our net force equations. Really, this one's not going to be super useful. It's just going to be negative FTX plus FTX equals 0. That's not going to tell us very much at all. The important one is some of the forces in the y direction, because now we're going to have FTY plus FTY, so 2 times FTY minus FG is going to equal 0 because it's not moving. We can solve for FTY. That's a fine thing to do for here. And we've got 2 FTY minus 392.4 newtons, 0 newtons. We're going to add this over to the other side. We get 2 FTY equals 392.4 newtons. We divide both sides by 2, and we get FTY is 392.4 on 2. That's going to equal 196.2 newtons. Now, that's not the force along the wire. That's just the force component in the y direction that's countering FG. So we need to figure out what exactly is. If we know this side here, how can we figure out FT? Well, as I mentioned in other videos, this side is the opposite angle is opposite to the angle. So if we're dealing with the opposites, we're dealing with sine of theta. Remember, is the opposite over the hypotenuse, or the if we multiply both sides by the hypotenuse, we're going to get the hypotenuse times the sine of the angle equals the opposite side. So in this case, our hypotenuse here is FT. We've got sine of 25, and that's going to equal FTY. So I can replace FTY with this. And I get FT sine of 25 degrees equals 196.2 newtons. And then to find FT, I'm just going to divide both sides by the sine of 25. These will cancel, and I'll get FT equals 196.2 divided by sine 25 degrees. And I get 464.2 newtons. Now, the key is slightly different. I use 9.81. Here, I believe the key used 9.8, which is why it's slightly different force. But that is well within tolerance. That's saying 464.2 newtons here and 464.2 newtons here. If you had them at 25 degrees, it would be enough to balance all these heavy, heavy bricks. All right?